And now the moment you've all been waiting for. Lesson 3.2. Solving systems algebraically. I'm so excited about this. Alright, so let's take a look at this system of equations right here. And you might ask yourself, why would I need to learn some other way to solve it? I already know how to solve it by graphing and by using my calculator. Well, let's check it out. Well, let's take a look at this. 3x plus 4y equals 12. I could subtract 3x from both sides, get my graph on. Negative 3x plus 12. Divide both sides by 4, and I get y equals negative 3/4 x plus 3. So my y-intercept is 0, 3. My slope is down 3 over 4. And I draw me a line. On this guy, if I subtract 2x from both sides, I get y equals negative 2x plus 10. So my y-intercept is 0, 10, and my slope is negative 2, down 2 over 1. And I draw me a line through there. Alright, now, where's my intersection point? Well, it looks like my intersection point's almost 6. Maybe like down 1. So is it 6, negative 1? Or is it like 5.8, negative 1.2, something like that? Well, I mean, we could check and try, right? Plug them in and see if they work. So if I was to plug into 3 times x plus 4 times y equals 12, if I did 6 and negative 1, 3 times 6 is 18. 4 times negative 1 is negative 4. 18 minus 4 is 14. Nope, that's not it. That's not it at all. Well, maybe it is really like 5.8 and negative 1.2. So let's do that. 5.8, negative 1.2. Let's see. 3 times 5.8 is 17.4. And then it's going to be negative 4 times 1.2. It's 4.8. And then 17.4 minus 4.8. Let's see. 17.4 minus 4.8 is 12.6. It's closer to 12, but it's not equal to 12. So what we get from this is that graphing isn't always the best. It only helps if a solution is like right on intersection points, right? So if it's a little bit off of an integer, if the solutions, the xy solution, aren't going to be integers, then graphing isn't very easy for that. We'd be guessing all day trying to get that right. Plus, then you got to consider, are you using a ruler? Are you using a pre-made graph? Are you using a graphing calculator? Because how accurate you draw your graph will determine how accurate your guesses are to see what the solution is. But in math, we don't love guessing. But let's take a look at the tables on the calculator. We did tables on the calculator before. So let's see. Let's do some tables on some calculators. Let's see. If I put it right here, I can still see both my equations. Okay, let's say y1 is negative 3/4 x plus 3. So negative 0.75x plus 3. And then y2 is negative 2x plus 10. Negative 2x plus 10. And now let's look at a table. Alright, let's see here. Now remember our intersection looked like it was around 6, negative 1. So when x is around 6, they're pretty close to each other, right? Remember, because it's supposed to be when x is 6, both y values are the same. So here we got negative 0.75 and 0. Back at 5. Then at 6. But we don't have a spot on our table that shows where the y values are equal, because it doesn't happen at an integer value of x. Well, I suppose we could try to cheat and look at the graph. Let's take a look at our graph. Maybe we could even zoom in on it. Let's zoom in on our graph. What is this going to do for us? Enter. Looking at my graph. Okay, now let's use the intersect tool. First curve is blue, second curve is red. My guess is right about here. So it says the intersection is 5.6 and 1.2. So that is one sort of cheater way to get it. But I'm going to show you the algebraic way to get it. You ready for this? Let's do it. So you can solve systems of equations by this method called substitution. And in substitution, we take one of the equations and isolate one of the variables, and then we plug that into the other equation. And I look and I see a good candidate right here. There's a y all by itself, sorta. It's got a plus 2x. If I was to isolate that y, I could then plug whatever I get into y in the other equation. So solve the equation for one of the variables. So I'm going to subtract 2x from both sides here, and I get y equals negative 2x plus 10. Step 2 is to substitute this expression into the other equation for y. So 3x plus 4y equals 12. Instead of this y right here, I'm going to put in negative 2x plus 10, because that's what y equals. Then I'm going to distribute 3x minus 8x plus 40 equals 12. Then I can simplify and solve for x, and I get x equals 5.6. Then I can take that 5.6 and plug back into either one of these equations to solve for y. The bottom equation looks easier because it already has y. I wouldn't have to divide by 4 to get my answer. So I'm going to plug it back in to whichever one's easier. So I know x is 5.6, so I'm going to plug 5.6 in for x. 2 times 5.6 plus y, 11.2. Subtract 11.2 from both sides and you get negative 1.2. Cool, huh? So using the intersect thing on the graph is going to be, it's going to be good if your answers are like a terminating decimal, a nice short terminating decimal. Other than that, it's not going to give you a fraction answer. If you got to put your answer in terms of the fraction, then the calculator is not going to help you there. So the solution is 5.6 comma negative 1.2. All right, so pause it and see if you got it. All right, I'm looking over here and I'm thinking this x right here is going to be the easiest one to get by itself. So I'm going to take x plus 3y equals 5, subtract 3y from both sides of the equal sign, and I get x equals negative 3y plus 5. And I'm going to substitute this expression in for x in the other equation. So negative 2 times x minus 4y equals negative 5. But what is x? It's this expression, negative 3y plus 5. Then I got to distribute. Negative 2 times negative 3y is positive 6y. Negative 2 times positive 5 is negative 10. Minus 4y equals negative 5. Combine like terms. 6y minus 4y is 2y. So 2y minus 10 equals negative 5. Add 10 to both sides. 2y equals 5. Divide both sides by 2. Y equals 5 over 2, aka 2.5 or 2.5. Alright, now that I know what the y value is, I can plug back into either one of these. This one has a negative 4 times. I'm going to use this one because the x is already by itself. This one looks easier to solve for x. So, x equal, here I already got the x by itself in this form right here. Negative 3 times y, which is 5 over 2, or 2.5, plus 5. So this is negative 15 over 2 plus 5. Negative 15 over 2 is negative 7.5. And negative 7.5 plus 5 is negative 2.5. So my solution to my system is negative 2.5, comma 2.5. It always goes x, then y. Ooh, piano lessons. I like piano lessons. A music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials, including music books, CDs, software, etc., are shown in the advertisement. What is the cost of each lesson and the one-time fee for materials? Alright, so 6 lessons is $300 and 12 lessons is $480, and that includes the cost for 6 lessons plus the one-time fee and the cost for 12 lessons plus the one-time fee. Prices include one-time fee. Alright, so how can we relate that? So for this one, there's 6 lessons. So 6 times the price of a lesson plus the fee equals $300. So 6 times the cost of one lesson plus the one-time fee is $300. For this one, it's 12 lessons, so 12 times the price of a lesson plus the one-time fee equals $480. 12 times the cost of one lesson plus the one-time fee is $480. So we're going to define. It would be divine if we could define C to be the cost of one lesson, so we'll call that C, and F to be the one-time fee. So we get a system of equations here. 6C plus F equals 300. 12C plus F equals 480. And then we just solve yonder equations. Let's pick one and isolate the variable. F looks easy to isolate. Just got to subtract 6C from both sides. Minus 6C, minus 6C, and F is 300 minus 6C. Then we're going to plug this expression for F into the other equation. So for this F right there. 12C plus the expression for F, 300 minus 6C, equals 480. 12C minus 6C is 6C, so 6C plus 300 equals 480. Subtract 300 from both sides. You get 6C equals 180. Divide both sides by 6, and then you get C equals 30. Once you know C equals 30, you can plug that back into one of the original equations. Or even easier would be if you plugged it back into that equation, because that would just be 300 minus 6 times 30. You've already done the solving. You don't need to do it over there. 300 minus 180, which equals 120. which is the same thing that you would get if you plugged it into this equation. So remember, this equation here was just this equation with f isolated. So they're equivalent equations. You could do the 180 here and then subtract 180 from both sides, and you'd still get f equals 120. So what does that mean? That means that the cost of a lesson is $30 per lesson, and the one-time fee is $120. All right, pause it and see if you got it. Okie dokie. An online music company offers 15 downloads for $19.75 and 40 downloads for $43.50. Each price includes the same one-time registration fee. So what is the cost of each download and the registration fee? Okay, so 15 times the number of downloads. I'm just going to define as I go. I'm going to say D is the number of downloads plus the registration fee equals, let's see, 15 downloads on the registration fee was $19.75. And then the other equation is 40 downloads, so 40 times D plus the one-time fee equals $43.50. Alright, I need to solve one of these guys for f. So if I subtract 15D from both sides here, I get f equals 19.75 minus 15D. And now I can substitute that in for f here. So 40D plus my f expression, which is 19.75 minus 15D equals $43.50. 40D minus 15D is 25D. I want to get D by itself. I'm going to undo addition before I undo division. So I'm going to subtract 19.75 from both sides, which give me 25D equals 23.75. Then to solve for D, I just need to divide both sides by 25, and 23.75 divided by 25 is 95 cents. So D, the cost of one download, is 95 cents. Am I done? No, because I need to know what the registration fee is. So I can plug back into F equals 19.75 ... There's something in the middle here. Minus 15 times 0.95. 1975 minus 15 times 0.95 is 1425. So the one-time fee is $5.50. So there's a $5.50 registration fee, and you pay 95 cents per download. And your code phrase is buffalo chip. Buffalo chip. Now I'm going to show you another method of solving systems of equations algebraically, which happens to be one of my favorites. Did you know that you can add two equations together and get an equivalent equation? For example, I'll show you over here. 3 equals 3. That's a true equation, right? 5 equals 5. That is also a true equation. I can add these equations together and I get 8 equals 8, which is also a true equation. So I'm allowed to add equations together, and then what I get is an equivalent equation. So if we are lucky enough to have one variable cancel out by adding equations, it makes our life easier, because that will get rid of 4x minus 4x is 0. No more x. So we would just get 2y plus 3y is 5y equals 9 plus 16, 25. Then I can divide both sides by 5 and get y equals 5. Then I can plug that 5 into either one of these equations for y and then solve for x. I believe we picked this one just because it has a positive 4 instead of the negative 4, which seems like it's a little bit easier to solve perhaps. So I'm going to plug the 5 in for y using the substitution property. 2 times 5 is 10. Subtract 10 from both sides. 4x equals negative 1. Divide both sides by 4. And we get x equals negative 1/4. So the ordered pair is negative 1/4, comma 5. Why don't you pause and see if you got it? All right, let's see what happens when we add these equations straight down. Negative 2x plus 5x is 3x. Positive 8y plus negative 8y is 0. And negative 8 plus 20 is 12. Divide both sides by 3, and we get x equals 4. I can plug a 4 into either one of these equations. I'm going to plug it into the top one because that's where our y has a positive coefficient. Negative 2 times x, which is 4, plus 8y equals negative 8. So that's negative 8 plus 8y equals negative 8. Add 8 to both sides, and we get 8y equals, let's see, negative 8 plus 8 was 0, so 0 plus 8y is 8y. Negative 8 plus 8 is 0, so 8y equals 0. Divide both sides by 8, and y equals 0. So the solution to these systems is 4, 0. Now remember, that means if you graph these lines, they would intersect at the point 4, 0. All right, now, even if your systems don't line up perfectly, where you have a positive 8y and a negative 8y, if you have a positive 4x and a negative 4x, we can use a little algebra to make one of the variables cancel out. How is it done? Well, looky here. I got 2x and 3x, and I got 7y and 5y. These numbers are smaller, so I'm going to pick these to manipulate to make things cancel out. If I was to multiply equation 1 times 3, and then multiply equation 2 times negative 2, what would happen to this first term? 2x times 3 is 6x. 3x times negative 2 is negative 6x. Then they would cancel out. So here's what I'm going to do. 2x plus 7y equals 4. And 3x plus 5y equals negative 5. So this first equation, I'm going to multiply both sides by 3. And this second equation, I'm going to multiply both sides by negative 2. 3 times 2x is 6x. 3 times 7y is 21y. 4 times 3 is 12. Negative 2 times 3x is negative 6x. Negative 2 times 5y is negative 10y. And negative 2 times negative 5 is positive 10. Now you might notice that I have 6x and negative 6x. So if I was to add these equations, my x's would cancel out. 6x minus 6x is 0. 21 minus 10 is 11, so we get 11y equals 12 plus 10, 22. Divide both sides by 11, and y equals 2. So there is half of our solution. The next half is plugging y into one of these equations. I would rather divide by 2 than divide by 3, so I'm going to plug into the top equation. So 2x plus 7y equals 4, and I know now that y equals 2. So 2x plus 14 equals 4. Subtract 14 from both sides of the equation, and you get 2x equals negative 10. Divide both sides by 2, and x equals negative 5. So my solution is negative 5, 2. All right. Why don't you pause the video and see if you can do this problem? This one right here. Solve that system. I dare you. Okay, let's do it. So, on this one, it doesn't really matter which one you go for, the x's or the y's. So let's say we want to get rid of the y's. See, 3 times 5 is 15, 7 times 2 is 14, so 14 is smaller. Let's just do that. Okay, so that means I'm going to take the top equation and multiply it by 2, and then the bottom equation and multiply it by negative 7, because that would give me 14y and negative 14y. So 3x plus 7y equals 15, and 5x plus 2y equals negative 4. I'm multiplying both sides of the first equation by 2, because that'll give me 14y. And I'm multiplying both sides of the second equation by negative 7, because that would give me negative 14y. So, distribute. 2 times 3x is 6x. 2 times 7y is plus 14y. 2 times 15 is 30. Negative 7 times 5 is negative 35x. Negative 7 times 2y is negative 14y. Negative 7 times negative 4 is positive 28. I got positive 14y and negative 14y. So, if I add these equations, I will get an equivalent equation with no y in it. So 6 minus 35 is negative 29x. 14y minus 14y is 0. And that equals 30 plus 28, 58. Divide both sides by negative 29. And we get x equals negative 2. So that's half of our solution. So if my solution goes right here, it's going to be 2 comma something. So I'm going to plug my, negative 2, sorry. Negative 2 comma something. Now I need to plug my negative 2 into one of these equations of her to figure out what y is. And I would rather divide by 2 than divide by 7, so I'm going to plug it into the bottom equation. So 5x, x is negative 2, plus 2y equals negative 4. 5 times negative 2 is negative 10, plus 2y equals negative 4. Add 10 to both sides. And we get 2y equals 6. Divide both sides by 2. And y equals 3. So the solution to this system of equations is negative 2, 3. Ding! Ooh. Solving systems without unique solutions. That means there's not just one solution. So what are the solutions to the following systems? Explain! Well, what happens when I add these? Negative 3x plus 3x is 0. Y plus negative y is 0. Negative 5 plus 5 is 0. So I get 0 equals 0, which is always true. The two equations in this system represent the same line. Therefore, it's a dependent system with infinitely many solutions. Every point on the line is a solution to this system. What about this one? 4x minus 4x is 0. Negative 6y plus 6y is 0. 6 plus 10 is 16. So we get 0 equals 16, which is never true. So these two equations represent parallel lines that never intersect. Therefore, it is an inconsistent system, and it has no solutions. So, pause it and see if you can figure out the solutions to these systems. Oakley dokley. So let's see here. If I was to multiply both sides of this top equation by 2, I would get negative 2x plus 2y equals negative 4. Now if I add these two equations, I get 0 plus 0 equals negative 4. 0 equals negative 4. Not in my lifetime. So we have an inconsistent system with no solution. Inconsistent, spelled incorrectly, and fixed with magic. Alright, so look at this system. If I was to multiply the top and bottom, the left and right side of this top equation by, I don't know, negative 3, that would make negative 12x, and the x's would cancel. So I would get negative 12x minus 3y equals negative 18. Now, if I add these two equations, I get 0 plus 0 equals 0, which is always true. So that tells me I got infinitely many solutions to this dependent system. And now we're at the end of the video, and I'll see you in the submissions thing. Bye.